Roadbond EN1 will maximize the benefit of conventional stabilizers, such as Portland cement and Flyash. This advantage allows one to reduce the amount of Portland cement or Flyash required to achieve the intended strength of the treated material. Reducing conventional stabilizers will save time, reduce trucking expense, and reduce airborne dust particulate at the job site. Also, the production of Portland cement consumes vast amounts of energy, water, and other natural resources, plus emits hazardous air pollutants such as CO2, mercury, arsenic, and lead. Roadbond EN1 offsets the negative environmental impact of Portland cement, reduces the carbon footprint of the project, and advances a more sustainable environment. Numerous tests clearly show a significant strength gain when Roadbond EN1 is combined with conventional stabilizers. For example, the Texas Department of Transportation conducted lab strength tests on pit-run gravel base and 4% Flyash, with and without Roadbond EN1. The result is an increase from Class 2 base with Flyash alone to Class 1 base, simply by adding Roadbond EN1 to the mix design. In a similar test, TxDOT added 2% Flyash to limestone base with and without Roadbond EN1. Roadbond EN1 increased the unconfined strength by 400%. The same test indicated that 4% Flyash plus Roadbond EN1 improved the unconfined strength by over 200%. TxDOT conducted a field test evaluating 7% Flyash with and without Roadbond EN1 on U.S. Highway 83. The contractor stabilized the reclaimed in-place material with 7% Flyash, and for comparison, a section with 7% Flyash plus Roadbond EN1. Both sections were tested 30 days after construction using the Kessler Dynamic Cone Penetrometer. The device is handheld and equipped with a 17.6-pound weight that drops 22.6 inches and strikes an anvil. These blows drive a 7/8-inch diameter cone into the ground, and the penetration depth is measured. Once the data is obtained, the number of blows delivered to the anvil and the total penetration depth are entered into a Microsoft Excel template that was developed by the U.S. Army Corps of Engineers. The template mathematically converts the raw data to CBR. At 30 days, the CBR of the control section was 142, and the CBR of the Roadbond EN1 improved section was 179. That is a 26% strength increase. 5 months later, both sections were tested again, and the difference is even more significant. At that point, the CBR of the Roadbond EN1 improved section had increased to 274, and the CBR of the Flyash section had decreased to 134. Roadbond EN1 gained 53% more strength from 30 days to 6 months, while the Flyash lost 6% strength. After 6 months, Roadbond EN1 is over 2 times stronger than the Flyash alone, and the strength had increased over time. As a further benefit, Roadbond EN1 delays the onset and reduces the magnitude of block or reflective cracking. The city of Fort Worth, Texas, reclaimed a portion of Floyd Road using Roadbond EN1 and 3% Portland cement. The remaining section of Floyd Road was rebuilt traditionally using 6% Portland cement. 8 years later, the control section has many cracks and extensive repairs, while the Roadbond EN1 improved section has very few cracks and no base failures. The city of Fort Worth then duplicated the field trials on other projects, including Earl Street. The east end of the street was rebuilt using 3% Portland cement plus Roadbond EN1, and the west end of the street was rebuilt as usual using 6% Portland cement. After 4 years, the Roadbond EN1 section has very few cracks, and the traditional section has extensive block cracks. After 8 years and extensive maintenance on the section without Roadbond EN1, the difference is even more impressive. 18 to 20 years after construction, 3 of the initial trial streets were tested for strength using the Kessler DCP. The average CBR of the 3 streets using 6% Portland cement was 210, whereas the average CBR of the 3 streets using 3% Portland cement plus Roadbond EN1 was 349. Not only did the streets require less maintenance over time, but also years after construction, the Roadbond EN1 treated streets were, on average, more than 60% stronger. Much like the city of Fort Worth, the city of Louisville, Texas, has used full-depth reclamation at 6% Portland cement to rebuild existing city streets. In 2004, this practice was modified by reducing the Portland cement to 3% and adding Roadbond EN1. After 1 year, the Roadbond EN1 sections have very few cracks. However, the cement-only sections have significant cracking, which is common for cement-treated soil. After 4 years, the cement-only sections have many cracks that have required maintenance and several areas that have failed badly. On the other hand, after 8 years, the Roadbond EN1 improved streets were still in remarkably good condition. Some cracks have occurred, but overall, the streets have required very little maintenance. 12 years after construction, the Roadbond EN1 improved streets were tested for strength with the Kessler DCP, and the average CBR strength is 229. Numerous drilling locations and lease roads have been constructed using the Roadbond EN1 advantage. For example, in the Eagle Ford Shale Formation, a series of drilling locations were tested several weeks after construction for in-place CBR using the Kessler DCP. Initially, one drilling location received the usual 8% Portland cement, and another location received 4% Portland cement plus Roadbond EN1. The 8% Portland cement location had an average CBR of 68, while the Roadbond EN1 improved location had an average CBR of 97. That is 50% less Portland cement and 43% more strength. The tests indicate that Roadbond EN1 soil stabilizer does add significant strength to the treated locations with less Portland cement. So on future locations, the amount of Portland cement was reduced from 8% to 3% plus Roadbond EN1. The average CBR of 3 locations stabilized with 8% Portland cement is 63. The average CBR of 10 locations stabilized with 3% Portland cement plus Roadbond EN1 is 78. That is 62% less Portland cement and 24% more strength. These are just a few of the many projects improved by using Roadbond EN1. Roadbond EN1 produces a significant strength gain, saves time and money during construction, and reduces truck traffic and harmful airborne dust particulate at the job site. Roadbond EN1, furthermore, conserves natural resources and promotes sustainability by reducing the need for conventional stabilizers that have a negative impact on the environment. Maximize your next project and go green with Roadbond EN1.